August 4, 1942. Henschel Werk III, Mittelfeld District, Kassel, Germany. Chief designer Erwin Aders stood in Shop 3, staring at hull number 25001, the first production Tiger, scheduled to leave the factory in exactly 11 hours. His hands trembled as he signed the inspection certificate. The specifications called for 300,000 man-hours per tank. The Waffenamt demanded 25 per month. Every engineer said it was impossible. In 18 months, they would produce 1,147 Tigers that would destroy over 10,000 Allied tanks. But on this August morning, Aders knew only one thing. The factory wasn't ready, the workers weren't trained, and Adolf Hitler expected his superweapon to change the war. The Tiger tank wasn't born in a design office, it was forged in panic. On June 22, 1941, German forces encountered Soviet T-34s and KV-1 heavy tanks on the Eastern Front. Nothing in the Wehrmacht arsenal could penetrate them at combat range. The 50 Merz and 75 mm guns that had dominated Poland and France bounced off Soviet armour like pebbles. German tank crews died in burning Panzer IIIs, frantically radioing that they faced invincible opponents. Henschel designer Erwin Aders later recalled the mood. There was great consternation when it was discovered that the Soviet tanks were superior to anything available to the Heer. Hitler's response was immediate. On May 26, 1941, 4 weeks before Barbarossa even launched, he ordered Henschel and Ferdinand Porsche to submit designs for a 45-ton breakthrough tank. The deadline, Hitler's birthday, April 20, 1942. 11 months to design, prototype, and demonstrate a tank heavier than anything Germany had ever built. The strategic necessity was brutal and simple. Germany needed a heavy tank capable of front-line breakthrough operations against fortified positions. It required 100 mm frontal armour, thicker than any existing German tank. It needed to mount the 80 mm Flak gun, a weapon so powerful it could destroy T-34s at 1,500 meters, but so large no existing turret could accommodate it. The mathematics were unforgiving. 57 tons final weight, 700 horsepower required, 8 interleaved road wheels per side to distribute ground pressure below 1.0 kilojoules per square centimetre. And it had to be manufactured by workers who built locomotives. Henschel und Sohn traced its origins to 1810, when Georg Christian Karl Henschel founded a small factory in Kassel. His son Karl Anton Henschel expanded operations in 1837. By 1848, the company began manufacturing locomotives. By the 20th century, Henschel had become Germany's largest producer of railway engines. When World War I erupted, the company pivoted to armament production. After Versailles Treaty restrictions, it returned to locomotives, trucks and buses. By 1925, Henschel began building buses and trucks. The rise of the Third Reich in 1935 brought weapon contracts again, first the Panzer I in early 1935, then Panzer III production from 1939-1940, but heavy tanks, that was uncharted territory. The company's 3 facilities sprawled across Kassel like an industrial archipelago. Werk IV in central Kassel specialized in locomotive assembly and artillery production. Werk II in the Rothenditmold district consisted of a massive foundry, boiler manufacturing, and locomotive component shops. Werk III at Mittelfeld, primarily devoted to tank assembly, would become the birthplace of the Tiger. But Werk III had a critical problem that would define Tiger production forever. The factory couldn't weld or bend heavy armour. The massive plates, 100 mm thick at the front, 80 mm on the sides, 26 cm on the roof, required specialized equipment and expertise Henschel simply didn't possess. The welding techniques for such thick armour required temperatures and precision beyond locomotive manufacturing standards. Krupp in Essen, 200 kilometers west, fabricated the hull armour using massive presses and specialised welding equipment. Dortmund Hürder Hüttenverein produced additional hulls when demand increased. Wegmann and Company, conveniently also located in Kassel, manufactured the turrets. The 88 mm KWK 36L56 guns came from DHHV in Dortmund, not far from Essen. This sprawling supply network spanning western Germany meant that Shop 3 at Mittelfeld became an assembly plant, not a complete manufacturing facility. Raw hulls arrived by rail as welded steel boxes. Workers received them with rough holes bored for suspension arms, final drives, vision ports, and hull machine gun mounts. Everything else, every mounting point, every bracket, every precise alignment, had to be machined to tolerances measured in tenths of millimetres. Production manager Robert Pertus stood at the railway siding that first morning in August 1942, watching the initial Tiger hulls being crane-lifted from flat cars. The specifications seemed designed to intimidate even experienced engineers. Each hull weighed 52,250 kilograms before any components were installed. Combat weight would reach 57,250 kilograms fully loaded with crew, ammunition and fuel. The dimensions challenged every assumption about what could be built and transported. 8.45 meters long with gun forward, 3.56 meters wide with combat tracks, 3.1 meters tall to the commander's cupola. But what truly terrified Pertus was the timeline Hitler demanded. The Führer wanted Tigers in combat immediately. The factory had 14 days to complete each tank from hull receipt to final inspection. They had 8,000 workers total, but not all were dedicated to tank production. Half the factory still built locomotives because the Reichsbahn desperately needed rolling stock. Shop 3 would assemble Tigers on the right side, while Shop 3's left side continued building locomotives side by side. The contrast was surreal, medieval weapons of war taking shape beside peacetime passenger engines. The solution was German industrial engineering taken to its logical extreme, the takt system. Takt meant rhythm, timing, industrial choreography executed with precision. The Tiger would move through 9 precisely timed stations, 9 Takte, each lasting exactly 6 hours. No more, no less. Factory photographs from 1942-1944 show the signs painted on shop walls in bold letters. Takt 1, Takt 2, Takt 3, progressing systematically through Takt 9. Worker Friedrich Müller reported to Shop 3 on August 10, 1942, for his first shift on the Tiger production line. His background was locomotives, specifically drilling mounting holes for boiler plates. Precision work, certainly, but nothing prepared him for the Tiger. Now he faced a raw Tiger hull at Takt 2. The instructions were precise to the point of obsession. Drill 52 holes for suspension arm mounting, each hole 45 mm diameter. Tolerance plus or minus 0.05 mm, 50 microns. Misalignment by 1/10 of a millimeter would cause the entire suspension to bind during operation. At combat speeds, such binding could break torsion bars or snap suspension arms. He worked alongside 11 other men at Takt 2. Their shift, 12 hours straight, with 2 brief meal breaks. When they finished at 1900 hours, the night shift took over. But Pertus quickly learned a harsh reality. The night shift produced only 50% of the day shift's output. Fatigue, darkness. Despite electric lighting, reduced supervision, all combined to slow everything down. Takt 1, hull receipt and movement from railway siding into Shop 3. The raw hulls weighed 52 tons. Moving them required specialized wheeled dollies and overhead crane systems. 4 workers guided each hull through the massive sliding doors into position at the first machining station. The process took approximately 2 hours, including positioning and securing. Take T2 and TAC T3, precision drilling and machining operations. These two tacti consumed 12 hours combined, holes for suspension arm mounting, holes for drive sprockets and final drives, holes for the hull machine gun mount, holes for driver and radio operator vision ports. Each location marked on engineering drawings with measurements taken from reference points established by Krupp during hull fabrication. Deviation meant scrapping the hull or extensive rework that could take days. TACT 4. Hull preparation completion and internal fitting, installation of internal brackets for ammunition storage, mounting points for radio equipment verified and drilled, driver and radio operator positions machined to final dimensions with seat mounting points installed, floor plates fitted, internal wiring conduits installed, 6 hours of painstaking detail work. TACT 5. Drivetrain installation, the heart of the Tiger. The Maybach HL 230P30 engine was a beast, 700 horsepower from 12 cylinders, 23 litres displacement, weight, 200 kilograms of cast aluminum and steel. Lowering it into the engine compartment required an overhead crane, 4 workers, and extreme precision. The engine mounts had to align perfectly or vibration would crack the hull. The Maybach Olvar OG40 1216 Model B transmission connected to the engine. This sophisticated gearbox provided 8 forward gears and 4 reverse gears. The transmission alone weighed 600 kilograms. Its installation required another 4 hours after the engine was secured. The steering gear, Henschel's development of the British Merritt-Brown system, connected to the transmission. This double differential system allowed the Tiger 16 different turning radii depending on gear selection. In first gear, the minimum turning radius was just 3.44 meters. In neutral, the Tiger could pivot in place by counter-rotating the tracks. TACT 6. Suspension installation, where German over-engineering reached its magnificent and problematic apex. This single tact consumed 12 hours per tank. The Tiger's suspension was unlike anything previously attempted. Each side carried road wheels in what the Germans called Schachterlaufwerk, an overlapping and interleaved arrangement. 24 wheels per side in early production. Each wheel was 800 millimeters in diameter. 3 wheels mounted on each of 8 suspension arms. The wheels on one suspension arm overlapped the wheels of adjacent arms. The theory was brilliant. This arrangement distributed the Tiger's 57-ton weight across maximum surface area. Ground pressure, 0.735 kilograms per square centimeter. This was lower than the M4 Sherman at 0.96 kilograms per square centimeter. Lower than the T-34 at 0.85 kilograms per square centimeter, a 57-ton tank that could traverse soft ground better than medium tanks half its weight. The ride quality was exceptional. Crews reported that the Tiger rode more smoothly over rough terrain than lighter Panzer IVs, but the reality proved more complex. The interleaved wheels created a maintenance nightmare that would haunt Tiger crews throughout the war. Removing an inner wheel that had lost its solid rubber tire, a common occurrence, required removing up to 9 other wheels first. This process could take an entire day in field conditions. Worse still was the Eastern Front winter problem. During the autumn Rasputitsa mud season, the road wheels became packed with thick, viscous mud. As temperatures dropped below freezing overnight, this mud froze solid between the interleaved wheels. The tracks froze in place. Tigers would sit immobile each dawn, completely helpless, until crews spent hours chipping ice and thawing wheels with blowtorches. Soviet intelligence quickly identified this vulnerability. Soviet doctrine soon incorporated dawn attacks, hitting German positions at first light, before crews could thaw their Tigers. German tank commanders began ordering crews to rotate the tracks every 2 hours throughout the night to prevent freezing. This exhausting practice meant crews got no sleep before combat. The torsion bar suspension system ran transversely across the hull bottom. 9 torsion bars per side. Each bar was a steel rod, approximately 40 mm in diameter and 2 meters long. When the road wheel hit an obstacle, the suspension arm twisted the torsion bar. The bar's resistance to twisting provided the spring effect. Hydraulic shock absorbers fitted to front and rear suspension arms damped oscillations. The system provided excellent ride quality, but required precise installation. Torsion bar mounting points had to be machined to exact specifications, or the bars would crack under stress. By January 1944, material shortages forced a redesign. The rubber-tired wheels proved unable to handle the Tiger's weight consistently. Rubber shortages due to Allied naval blockades made the situation worse. Henschel introduced steel-rimmed wheels, flat designs without rubber tires. These steel wheels were stronger and could carry more weight. The engineers reduced the wheel count from 24 to 16 per side, removing the outermost row entirely. 2 wheels per suspension arm instead of 3. The steel wheels increased internal noise and vibration, adding to crew fatigue. But they solved the rubber shortage problem and simplified field maintenance slightly. TKT-7 final drive and track installation. The Tiger used 2 completely different track systems. Combat tracks, 721 mm wide, 96 links per track. Transport tracks, 500 mm wide, designed for rail transport. The combat tracks were absolutely necessary for achieving low ground pressure. Their width spread the Tiger's weight effectively across soft ground. But they created an enormous problem. They made the Tiger 3.56 meters wide. German railway loading gauges typically allowed only 3.15 meters maximum width. The Tiger was too wide to fit on standard railway flat cars. The solution was cumbersome and time-consuming. Before rail transport, crews had to remove the outer row of road wheels on each side. Then they removed the wide combat tracks. Then they installed the narrow 500 mm transport tracks. Then they loaded the removed combat tracks onto the flat car separately. This entire process required 4 hours with experienced, well-trained crews. In combat zones with limited maintenance facilities and exhausted crews, track changes could consume an entire day. When Tigers reached their destination, the entire process reversed. Remove narrow tracks, install wide combat tracks, reinstall outer road wheels. Then, and only then, was the Tiger combat ready. Some commanders simply refused to conduct track changes. They operated with combat tracks permanently installed. This meant Tigers couldn't be transported by rail efficiently. They had to be driven to combat zones under their own power. At 60 miles per journey, consuming 150 gallons of fuel, this quickly depleted Germany's shrinking fuel stocks. TAC T8, turret installation and final assembly. The Krupp turret arrived from Wegmann's facility across Kassel by rail. Weight, 11,000 kilograms without the main gun. The 88mm KWK 36L56 cannon added another 1,130 kilograms. The completed turret with gun, sights, ammunition and internal equipment weighed approximately 13,000 kilograms. Mounting the turret required Shop 3's specialized overhead crane system. 4 experienced workers guided the turret into position. Engineers used precision instruments to verify turret ring alignment. The turret ring was exactly 1,150 millimeters in internal diameter. Misalignment of even 2 millimeters would cause the turret to jam during traverse. In combat, a jammed turret meant a dead tank. The 80 Imipurus KWK-36L56 gun itself was a marvel of German weapons engineering. Derived from the legendary 80mm Flak 36 anti-aircraft gun that had terrorized Allied bomber crews, it had been brilliantly modified for tank use. The barrel length was 56 calibers, meaning 56 times the 80mm bore diameter. This translated to 4.93 meters of rifled steel tube. The gun fired Panzergranate 39 armor-piercing capped ballistic cap rounds at a muzzle velocity of 773 meters per second. The more advanced Panzergranate 40 tungsten cord rounds achieved 930 meters per second. At 1,000 meters range, the PZGR-40 could penetrate 138 milliliter of armor plate. At 2,000 meters, it could still penetrate 100 millimeter. The Sherman's 75 mm M3 gun, by comparison, could penetrate only 68 metum at 500 meters. Against the Tiger's 100 mm frontal armor, the Sherman stood no chance at any range. The 75 mm rounds simply bounced off. British wartime firing trials at captured Tiger 131 documented the gun's terrifying accuracy. Test crews scored 5 successive hits on a 16 by 18-inch target at 1,200 yards. That's a target roughly the size of a human torso at over a kilometre distance. The Leitz TZF-9B telescopic sight, later replaced by the improved monocular TZF-9C, provided precision optics that made such accuracy possible. German optical engineering was unmatched. Tiger crews could identify and engage Allied tanks at ranges where Allied crews saw only indistinct shapes. The ammunition arrangement inside the Tiger's turret and hull was carefully planned. Total ammunition stowage, 92 rounds, 16 rounds stored in the turret bustle for immediate access by the loader. The remaining 76 rounds stored in hull bins, requiring the radio operator to pass shells forward. Each round weighed between 10 to 15 kilograms, depending on type. The loader's job was physically exhausting during extended combat. Sustained firing rates quickly led to loader fatigue. Take T9. Final painting, coating, and quality inspection. From late 1943 onward, Tigers received Zimmerit coating. Zimmerit was a paste mixture applied in ridged patterns to the hull and turret. The purpose: defeat magnetic anti-tank mines. Soviet forces had begun using magnetic mines that adhered to steel armor. The ridged Zimmerit prevented mines from making solid contact. Application required several hours and added approximately 100 kilograms to the tank's weight. Factory camouflage was never applied at Henschel. Tigers left the factory in dark grey primer RAL 7021. Field units applied their own camouflage schemes based on operational environment. Eastern Front units used white winter wash. Western Front units applied 3-colour patterns of dark yellow, red-brown and olive green. Inspector Hans Kruger's Takt 9 checklist was exhaustive. Engines started and run for 30 minutes at varying RPMs. Oil pressure monitored. Coolant temperature checked. Transmission cycled through all 12 gears, 8 forward, 4 reverse. Each gear tested under load. Turret traversed 360 degrees both manually and with powered traverse. Gun elevated from 8 degrees depression to 117 degrees elevation. All hatches opened and closed to verify seals and hinges. Commander's cupola rotated smoothly. Machine guns test-fired with blank ammunition. Radio equipment tested with other factory radios. All periscopes cleaned and aligned. Track tension measured on both sides. Brake system tested. Steering tested at multiple gear settings. Only after this comprehensive inspection did Kruger sign the acceptance certificate. Only then did hull number 25001 officially become a combat-ready Tiger tank. The entire process, from hull receipt at Takt 1 to final inspection at Takt 9, required 14 days. But that was the theoretical minimum. Reality constantly diverged. The factory employed 8,000 workers for tank production. They worked 2 12-hour shifts, but the night shift produced only half the day shift's output. This meant effective labour was equivalent to 6,000 day shift workers. At any given time, 18 to 22 Tiger hulls occupied the main assembly line, moving through tacte 1 to 6. The final assembly line held approximately 10 Tigers simultaneously at tacte 7 to 9. This meant the factory floor always contained approximately 30 Tigers in various stages of completion. Even with perfect efficiency, initial production couldn't exceed 25 Tigers per month, and efficiency was anything but perfect. Component shortages disrupted production constantly. Rubber for road wheel rims vanished as Allied bombing and naval blockades strangled synthetic rubber production. By January 1944, steel wheels replaced rubber-rimmed ones entirely. Precision parts from subcontractors arrived weeks late. Final drives failed quality testing, requiring replacement units from Maybach. The Maybach engines themselves occasionally failed inspections, forcing delays while replacement engines were shipped from Friedrichshafen. Turrets from Wegmann sometimes arrived with turret rings that didn't match hull specifications exactly. Machine work could fix minor mismatches, but major deviations meant sending turrets back. Production manager Pertus faced a cruel mathematical reality. Each Tiger required 300,000 man-hours to complete. The factory had 8,000 workers. Simple division suggested each worker contributed 37.5 hours to each tank. But workers weren't interchangeable components. Specialized skills, precision machining, welding, electrical work, hydraulic systems, turret installation, couldn't be redistributed evenly across the workforce. Then there was the cost that revealed Germany's strategic miscalculation. Each Tiger tank cost 250,800 Reichsmarks to build. A Panzer IV cost 103,462 Reichsmarks. A Panther cost 117,100 Reichsmarks. The Tiger cost more than 2 Panthers combined. For the price of 1 Tiger, Germany could build 2.5 Panzer IVs. American economists analyzing captured German production documents after the war calculated that a modern Tiger would cost approximately $1,282,051 to replicate using 2020's labour and materials. The engineering was magnificent. The economics were catastrophic. But Hitler didn't care about economics. He cared about psychological impact. He understood that 1 Tiger inspiring terror across an entire sector was worth more than cold statistics suggested. He was right about the psychological effect. He was wrong about the strategic outcome. The first Tiger crews arrived at Henschel in early 1942, while production was still ramping up. These weren't ordinary tank crews scraped together from replacement depots. The Wehrmacht hand-picked veterans, men who had fought through France, survived North Africa, or endured the Eastern Front. Only the best panzer troops qualified for Tiger battalions. Their training began in an unusual and inspired way. Crews spent several weeks inside Shop 3, actually helping to build the tanks they would later command. Worker Müller remembered them clearly, young lieutenants and Feldwebels, already wearing panzer badges and decorations, standing beside assembly workers at Tactor 5 and Tactor 6. They learned every bolt, every seal, every component, every system. They helped install engines at Tact 5. They assisted with suspension installation at Tact 6. They watched turrets being mounted at Tact 8. The theory behind this training was sound. Crews who understood construction could perform better field maintenance. They would know which components were critical and which repairs could wait. They would understand the Tiger's limitations and capabilities intimately. In practice, it worked brilliantly, initially. After their factory apprenticeship, crews moved to Paderborn for formal tactical and gunnery training. The training centre at Panzer Regiment 11 Barracks became the Tiger School, where crews learned actual combat employment. A specialised gunnery range at Putlos on the Baltic coast provided firing practice with live ammunition. Crews fired hundreds of rounds, learning the 80-Tinnenettens ballistics. To make training memorable and overcome young tankers' reluctance to study dry technical manuals, instructor Oberstleutnant Hans Christen commissioned something revolutionary. The Tiger Fibel, Tiger Primer, was unlike any military manual ever produced. It looked like a children's book. Cartoon illustrations featured an attractive, curvaceous blonde named Elvira. She was depicted naked or scantily clad as often as possible. Risque humour and everyday slang replaced official military terminology. Technical information was presented through jokes, cartoons, and memorable verses. The manual's creators, Unteroffizier Wagner and Obergrenadier Gessinger, who did the illustrations, and the writer who remains less documented, understood young men perfectly. If you want them to remember something, make it funny or sexual. Preferably both. It worked spectacularly. Crews quoted passages from the Tiger Fibel years later. They remembered maintenance procedures because they were associated with Elvira. They recalled gunnery principles because they were explained through humorous cartoons. The Tiger Fibel became legendary within the Panzerwaffe. Similar illustrated manuals were later produced for other vehicles. But as the war progressed and German fortunes declined, crew quality declined catastrophically. The best veterans, the men who had received factory training and months at Paderborn, died on the Eastern Front or in North Africa. Replacement crews arrived younger, less experienced, poorly trained, and often terrified. By 1944, Tiger crews no longer visited Henschel factories. They received abbreviated training at Paderborn, sometimes just weeks instead of months. Some arrived at frontline units having never fired the 88mm gun in training. Ammunition shortages meant training rounds simply weren't available. These crews learned to fight in Tigers during their first combat engagement. The learning curve was steep and often fatal. The Tiger required extensive daily maintenance that well-trained crews could manage. Oil levels checked every morning before starting. Track tension verified on both sides. All 48 interleaved wheels inspected for damage or rubber tire loss. Engine air filters cleaned. Transmission fluid level checked. Hydraulic fluid for turret traverse monitored. Brake systems tested. Final drive seals inspected for leaks. A well-trained, experienced crew could complete these checks in 90 minutes. An inexperienced crew might take 4 hours, or dangerously skip checks entirely. Skipped maintenance meant breakdowns. Breakdowns in combat zones with Allied forces approaching meant abandoned Tigers. German doctrine strictly prohibited using one Tiger to tow another. The strain could damage transmissions on both tanks. Instead, Tigers required 2 massive SDKFZ-9 FAMO half-tracks for recovery. These 18-ton recovery vehicles were never available in sufficient numbers. The brutal mathematics of Tiger losses tell the real story. German records document 1,725 Tigers lost during the war, including both Tiger the Farm and Tiger II variants. Only a fraction, perhaps 30%, fell to direct enemy fire. The majority were abandoned due to mechanical failure, transmission breakdowns, final drive failures, or simply running out of fuel. More Tigers were destroyed by their own crews to prevent capture than were knocked out by Allied guns. The Henschel factory's greatest test came on the night of October 22–23, 1943. RAF Bomber Command had been targeting Kassel periodically since 1941, but this raid was different in scale and ferocity. At 20:45 hours, air raid sirens wailed across Kassel. 5 minutes earlier, a fake diversionary raid on Frankfurt had launched to confuse German air defences. The Germans saw through the deception but couldn't respond effectively. Pathfinder aircraft marked the target zones with flares and incendiary markers. Then 569 Lancaster bombers came in successive waves. Each bomber carried a mix of high-explosive bombs and incendiary devices. Total payload, 1,800 tons of explosives, 460,000 incendiary fire sticks designed specifically to start fires. The bombing lasted approximately 2 hours. Kassel's medieval city centre, with its timber-framed buildings, became an inferno almost immediately. The city's water distribution system shattered in the first wave. Water mains broke. Pumping stations lost power. Firefighting became nearly impossible. The Henschel facilities were priority targets clearly marked on RAF maps. All 3 factory buildings of the armaments works were severely hit. Shop 3, the Tiger Assembly Hall, lost major sections of its roof. Structural supports collapsed. Shop 5 sustained damage that rendered a quarter of the floor space unusable. Storage sheds containing Tiger components, spare parts, and completed sub-assemblies burned completely. The fires burned for 7 days. At least 10,000 civilians died in Kassel that night. 150,000 inhabitants, more than half the city's population, were bombed out of their homes. The city's population of 236,000 in 1939 would shrink to just 50,000 by war's end. But the bombing's worst effect on Tiger production wasn't structural damage. It was human. Thousands of Henschel workers died in the raid. Thousands more were injured seriously enough that they couldn't return to work for weeks or months. Others fled the city entirely, never to return. The factory's workforce dropped by 3,500 employees immediately, nearly half the tank production staff. Production manager Pertus surveyed the ruins the morning of October 24, 1943. Tiger hulls sat exposed to autumn rain, their protective sheds reduced to blackened frames. Precision machine tools were buried under tons of concrete rubble. The overhead crane systems in Shop 3 required complete rebuilding. Weeks of work. Railway sidings were blocked by debris. Power systems were down. The factory seemed dead. Allied intelligence analysts in London predicted Tiger production would cease for at least 3 months, possibly 6. The 8th Air Force and RAF Bomber Command considered the Kassel raid a complete success. They were wrong about the production cessation. They underestimated German determination. 3 weeks after the bombing, on November 12, 1943, Tiger production resumed. Not at pre-bombing levels, output dropped from 50 to 60 tanks per month to perhaps 25-30. But it resumed. How? Workers cleared rubble by hand, working 14-hour days. Precision machine tools were excavated, assessed, repaired when possible, or replaced from other facilities. Alternative shop spaces were pressed into service. Equipment was relocated to undamaged sections. The night shift returned despite producing only half the day shift's output. Employment climbed back slowly as some workers returned, and forced labourers, approximately 6,000 by this point, filled critical gaps. The work continued through winter 1943 to 1944 under incredibly difficult conditions. Sections of Shop 3 had no roof. Workers assembled Tigers while snow fell on them. Temporary coverings were rigged. Heating was intermittent. But the TACT system continued. Tigers moved through the stations. By April 1944, production reached its absolute peak. 104 Tigers completed that month. This represented the highest monthly output ever achieved. This peak came 6 months after the devastating October bombing. Albert Speer's appointment as Minister of Armaments in 1942 had begun rationalizing German war production somewhat. Speer pushed for standardization, quality control and efficiency improvements, but German industry never fully embraced total war production methods until too late. Compare Henschel's achievement to American production. The Willow Run plant in Michigan built B-24 Liberator bombers at peak efficiency. One complete bomber rolled off the line every 63 minutes. Ford's River Rouge complex in Detroit employed true assembly line techniques perfected over decades of automobile production. Chrysler's Detroit tank arsenal produced M4 Shermans at rates that made German output look medieval. The fundamental difference wasn't German engineering skill, it was American industrial philosophy and resources. The production numbers tell the strategic story with brutal clarity. Germany produced 347 Tiger I tanks between August 1942 and August 1944, 24 months. That's an average of 56 Tigers per month. Germany produced 490 Tiger II tanks between January 1944 and March 1945, 15 months. That's an average of 33 Tigers per month. Total Tiger family production, 1,137 tanks over 32 months. The United States produced over 49,000 M4 Sherman tanks between 1942 and 1945. The Soviet Union built approximately 84,000 T-34 medium tanks in all variants. Britain manufactured approximately 25,000 cruiser and infantry tanks. The disparity wasn't just numerical, it was philosophical. German quality faced Allied quantity in an industrial deathmatch. Quality lost decisively. The Tiger's magnificent engineering excellence became its fatal strategic liability. Each Tiger required specialized parts that couldn't be mass-produced using American methods. The interleaved suspension was mechanically sophisticated, but maintenance-intensive. The 80-diameter KWK-36 gun used ammunition incompatible with any other German tank gun. This meant separate ammunition production lines, separate logistics chains, separate training. The Maybach HL 230 engine demanded high-octane fuel that became increasingly scarce after 1943, as Allied bombing destroyed synthetic fuel plants. Compare this fragility to the Sherman's robust simplicity. The M4 used various engines depending on production variant. Right radial engines, continental radials, even diesel power plants. Many Sherman engines were identical to aircraft engines, meaning parts commonality across the entire American military. The Sherman's vertical volute spring suspension was crude by German standards, but it was reliable, simple, and field repairable. Damaged suspension bogies could be replaced in field conditions in hours using basic tools. The 75mm gun used ammunition shared with other American vehicles, simplifying logistics enormously. Soviet T-34s were even more pragmatically designed with brutal efficiency. Christie suspension. Simple, rugged, easily repaired by barely trained crews. The V2 diesel engine, reliable, fuel-efficient, and using fuel types readily available. Sloped armor, revolutionary protection without requiring excessive thickness and weight. The 76mm gun, adequate against most German armor when used correctly. T-34 production philosophy emphasized quantity and good enough quality over perfection. Interior finish, crude, with rough welds and minimal comfort. Crew comfort, minimal, with crews often bruised from rough rides. Reliability, good enough to reach Berlin. That's all that mattered. One Soviet factory manager famously captured this philosophy. A tank that runs for 1,000 kilometers is a waste of resources. We need tanks that run for 500 kilometers to reach Berlin. After that, we'll build more. The Tiger ran for perhaps 200 kilometers before requiring major maintenance by skilled technicians. That maintenance required specialized tools, replacement parts, and hours of labor. When Tigers broke down 400 kilometers inside Soviet territory with no recovery vehicles available, they became pillboxes until crews destroyed them. Yet individual Tigers achieved results that justified Hitler's faith in psychological impact. Tank number 007 of Schwer Panzerabteilung 501 claimed 150 Allied tanks destroyed over its operational life. SS Obersturmführer Michael Wittmann's Tiger destroyed 138 enemy tanks and 132 anti-tank guns before Wittmann was killed in August 1944. Tiger 131, captured in Tunisia in April 1943, survives as the only running Tiger today, meticulously preserved at the UK Tank Museum in Bovington. These individual success stories masked the strategic failure. Germany needed 10,000 Tigers to change the war's strategic outcome. Henschel could produce perhaps 100 per month under theoretically ideal conditions. Ideal conditions never existed after October 1943. Even sustained production of 100 per month for 3 years would yield only 3,600 Tigers, far short of the needed quantity. Allied bombing escalated relentlessly throughout 1944. September 8, 1944, 243 American B-24 Liberators bombed Henschel facilities in daylight. September 22 to October 7, 1944, 5 RAF raids over 15 days destroyed an estimated 95% of Henschel's remaining floor area. Post-war analysis by American economists estimated these raids cost Germany approximately 657 Tiger II tanks that were contracted but never built. Yet somehow, impossibly, production continued. Workers assembled Tigers literally in the ruins. They worked by daylight when electricity failed permanently in sections of the factory. They improvised repairs when proper replacement parts weren't available. They used salvaged components from damaged tanks. Quality suffered dramatically. Late war Tigers had significantly higher failure rates than 1942 to 1943 production models. But they kept building until the very end. On March 9, 1945, the last major bombing of Kassel occurred. 176 RAF aircraft struck the shattered city once more. By then, little remained to destroy. The raids were more symbolic than strategic. April 1, 1945. The U.S. Third Army began the final battle to capture Kassel. American infantry and armor closed on the city from multiple directions. As they approached the industrial districts, Henschel workers completed 13 Tiger II tanks. These final Tigers, the last ever built, were driven directly from Shop 3 to Schwer Panzerabteilung 510 and 511 units defending the city. Crews who had never trained on Tiger IIs received them still warm from final assembly. Some crews had never even seen a Tiger II before. April 4, 1945, at precisely 1200 hours, Kassel surrendered to American forces. U.S. Army soldiers entered Werk III at Mittelfeld cautiously, expecting resistance. They found none. The factory was silent. Tiger production ended forever. The Henschel facilities sat in ruins that shocked even combat-hardened American soldiers. Shop 3 was barely standing, more rubble than building. Shop 5 had one wall remaining. Werk I and Werk II in other parts of Kassel were completely destroyed. But amid the rubble and devastation, evidence of extraordinary German craftsmanship remained. American technical investigators found precision machine tools buried under debris, some still in working condition. Engineering drawings recovered from fireproof safes detailed tolerances measured in hundredths of millimeters. Quality control records showed rejection rates for components that failed to meet specifications. Even under bombing, German quality standards remained absurdly high. Production logs meticulously documented every Tiger ever built. Hull numbers, delivery dates, modifications installed, acceptance test results. The USSBS, United States Strategic Bombing Survey, interviewed surviving Henschel managers in the weeks after surrender. One question dominated the interrogations: why did you continue building Tigers when the war was obviously lost for months? Production manager Robert Pertus, gaunt and exhausted, answered with German matter-of-factness: "We had orders from the Reichsministerium. We had workers who reported every day. We had some materials still arriving by rail. We built tanks. That was our job." The Tiger tank revealed fundamental truths about industrial warfare in the modern age. First truth: engineering excellence means nothing without production capacity to match. The Tiger was technically superior to almost any Allied tank in direct combat. Individual Tigers routinely achieved kill ratios of 10.1 or even 20.1 against Shermans and T-34s. But when the enemy can replace 10 tanks for every one you build, kill ratios become strategically irrelevant. The mathematics are brutal but decisive. Second truth: complexity is the mortal enemy of mass production. The Tiger's interleaved wheels, precision-machined components, and specialized parts made it a masterpiece of mechanical engineering. These same features made it impossible to mass produce using efficient methods. The Sherman and T-34, with their simpler designs and standardized components, could be manufactured by semi-skilled workers using mass production techniques. The Tiger required master craftsmen using custom tooling for nearly every major component. Third truth: strategic bombing works, eventually and cumulatively. The October 1943 raid on Kassel didn't stop Tiger production permanently. Neither did any single subsequent raid. But collectively, over 18 months, 40-plus raids reduced potential output by an estimated 6,557 plus tanks. More critically, the raids killed irreplaceable skilled workers. They destroyed precision machine tools that took months to rebuild. They forced constant production disruptions that killed efficiency. The cumulative effect was devastating even if individual raids seemed survivable. Fourth truth: industrial democracy outproduces fascist efficiency over time. German propaganda relentlessly emphasized discipline, organization, and superior German engineering. But American and Soviet factories, operating with market incentives, labor flexibility, entrepreneurial innovation, and capitalist competition, produced more, faster, and often just as well. The Tiger embodied German engineering excellence. It also embodied German industrial shortcomings and strategic miscalculations. The final statistics tell the story. Total Tiger 1 production: 1,347 tanks over 24 months. Total Tiger 2 production: 490 tanks over 15 months. Combined Tiger family: 1,137 tanks. Final production cost: 250,800 Reichsmarks per Tiger 1s, approximately 391,500 Reichsmarks per Tiger 2. American M4 Sherman cost: approximately $44,156, roughly 100,000 Reichsmarks at wartime exchange rates. Production ratio: for every Tiger Germany built, the Allies produced approximately 27 medium tanks. The Tigers destroyed over 10,000 Allied tanks during the war, according to German claims. Allied industry replaced every single one in a matter of weeks. Germany could not replace its 1,137 Tigers. When Erwin Aders signed that first production certificate on August 4, 1942, he believed he was creating a weapon that would change the war's outcome. In a certain sense, he was absolutely right. The Tiger proved conclusively that technology alone cannot win industrial wars. Production capacity, resource availability, logistics networks, and strategic bombing determine industrial conflicts. Germany manufactured the finest tank of World War II by most technical measures. The Allies manufactured 100,000 tanks that were good enough to win. Good enough won. Superior lost. That was the lesson. Today, Kassel remains an industrial city in central Germany. The Henschel factory complex survived in substantially altered form. parts of Werk III still stand, now housing a technical museum and cultural centre. Visitors can walk through the preserved spaces where Tigers were assembled 80 years ago. The railway siding where Tiger hulls arrived from Krupp is preserved as a memorial. Shop 3's footprint remains visible in the pavement. Only 9 Tiger wine tanks survive in museums and private collections worldwide. Tiger 131 at the Tank Museum in Bovington, England, the sole runner, maintained in operating condition, demonstrated at annual Tiger Day events. Tiger 712 at Fort Moore, Georgia, partially cut away for educational display, showing internal systems. Additional examples preserved in museums in France, Russia and Germany, all static displays. Each surviving Tiger represents 300,000 man-hours of labour by German workers. Each cost 250 800 Reichsmarks to build in wartime currency. Each required 14 days minimum to assemble in a factory that operated under constant threat of annihilation from Allied bombers. The workshop that built the Tiger tank stands as a testament to German engineering skill, worker dedication, and industrial organisation under impossible conditions. It also serves as a monument to strategic miscalculation on a civilizational scale. Germany built a super weapon when it desperately needed weapons in super quantities. The Tiger won tactical battles decisively. Mass production won the strategic war completely. The factory workers who assembled Tigers in the ruins of Kassel after the October 1943 bombing deserve recognition not as agents of a criminal regime, but as craftsmen who took pride in their work, even as their world literally burned around them. They built machines of terrible beauty and devastating battlefield effectiveness. They couldn't build enough to matter strategically. That was the Tiger's tragedy. That was Germany's industrial defeat. And that was the permanent lesson the world learned at Henschel Werk III, Mittelfeld, Kassel, Mittelfeld, Kassel, Mittelfeld, Kassel, Mittelfeld, Kassel, Mittelfeld, Kassel, Mittelfeld, Kassel, Mittelfeld,